Now we're going to start working on bulkhead number 2, which has the front wheel assembly and the associated hardware and components that get mounted on there. Here I have removed bulkhead number 2 from the float structure, and we're looking at the front side. And our first step is to do some markings. Now these are all in your plans, but basically I have the center line and I have 2 hinge lines, and these are measured from the top. And here's the second hinge line at the bottom. Now I also have another line right above it, which is where an extrusion will go on the back side, and that'll be the center line on the back side. We will also have an extrusion on the back side along the upper hinge line also. The holes you see in place here are from FL 150, the side walls, and I recommend drilling those after, not before like I did, but after we mount the hardware for the wheel on here. Now we're going to have to make some of the components. Here are some of the back extrusions, and these will be braces that go on the back side of our bulkhead. These are easy to make. We start out with a piece of stock extrusion and then form it by using our plans, our directions, to basically trim off these areas here and make it the proper length. And we also have a second one which we make. It's also important when using your bandsaw to cut these is to use a Scotch-Brite wheel or file with some more work to keep the edges nice and smooth and remove all of the teeth marks. So I have FL 53 here and FL 52, the shorter one here, and both of these will go on the back side. Now on the front we need to create our FL 66, and again we'll make this using our bandsaw, and our plans will show us the dimensions for cutting these down. These are also again made from a stock piece of L extrusion. So we'll have one left and one right of these so that they match up. Now these will end up going about like this. The area here will be where the pivot point will be, so that location will go along the pivot line that we previously drew. And then a pair of FL 61s, and these will go, actually these are out here. That looks better. Go like here. And these were prefabricated for us. And the hole will also go along our pivot line that we drew. And that will go approximately like that. FL 60, these were pre-made for us with the holes. And these will be located along the upper pivot line that we drew and situated as per our plans. Now before we rivet these to the bulkhead, we want to first lay out our holes for the rivets. Now the pitch is on your plans for the pitch separation, but we also want to be careful when laying this out that we intersect the proper locations as per our plans along the rear extrusions. Remember, we have 2 rear extrusions going along, and we want to make sure some of the holes, for example, I marked this hole here and this hole here, those will intersect with our rear extrusions, and that's why I drew these lines. And that way when we lay out the holes, we can make sure that we have a hole that goes through the center of the rear extrusion and another hole over here that goes through the center of the rear extrusion. And then from those holes we can lay out using our pitch with our rivet fan so that we get a nice consistent spacing, but at least we know that those two holes will fall where they are supposed to go. So I pre-drilled the holes as we just described. Now as far as the spacing from left to right, we want to do that carefully. Now up and down, of course, our pivot line matches up with the line we drew on the bulkhead. We have this component here. Now this will hold our tail, our nose wheel. And this will actually pivot in this location. In fact, let me turn this slightly sideways. And we'll drill two holes to the center on each side. And then for our spacing, we want to bolt this up. In other words, drill the holes through carefully and bolt it up with the proper hardware so that we get the proper spacing left to right, so we know that this will operate nicely as it goes. So I'm going to go ahead and create the pivot holes in our piece here. And of course the way I'm going to do that so that it is drilled properly is to lay these together, clamp them together, and lay them flat on a surface on our table so that they're nice and flat, and then clamp them together and then drill through the existing hole. And I'll do that for both sides, and then I can also drill this after I get the two holes in these pieces and drill straight through. So I know that everything's going to line up nicely, and then I'll use a bolt, and then we will position these and drill into the bulkhead. Here I have most of the components in place, clecoed in place, drilled with just number 40 holes. Here's our lower pivot location. I installed this with the arm in place so that I could get the correct width and spacing. Here's the upper pivot point. Now along this line and this line, we will find on the reverse side that we have our stiffeners in place, the extruded angles. So when planning this out, as far as the holes go, we want to put these in place because obviously we have some intersections between the horizontal stiffeners and the components on the other side. And we want to plan that out so that the rivet holes line up before drilling. And then finally, I'm going to go get FL 150, which is the side wall on both sides, and lay out the holes, again watching for the horizontal stiffeners on the back so that the holes line up at the intersections. And here I have the front wheel arm in place, and it pivots as such. And up here at the top we have the pneumatic cylinder, which hooks to our upper pivot point, and eventually these will be hooked together to allow the wheel to go up and down. We have a little more hardware to put on for that, but this at least demonstrates the purpose of these mounting points that we created. And at the bottom we use 1/4-inch bolts with plastic washers in between each of those locations. So we have a plastic washer between these two and these two pieces. And then we'll end up using castle nuts with cotter pins to secure those. Now on the rear side, down at the very bottom here, we have a gusset FL59, and this will be located right down in here. Now we'll back drill through our existing holes that we have on the front side, and then add some more holes till we have them all consistent across the side there. Now this is FL1, our very front bulkhead, and we're going to need to remove, this is the top. We're going to need to remove a large cutout for the front steering wheel, or the castering wheel. I've marked according to the plans, and the height is here. I'm going to start by cutting some at least 1/4 inch holes at these corners, and then I can use my snips to cut up, because we don't want sharp corners in the metal. That'll create some stress risers. So we'll have nice rounded corners, and we'll go ahead and cut this section out. And we'll go ahead with a file and clean up the edges. And here's a view of the nose wheel mechanism. We have our bolts temporarily installed here. Our piston will attach down at the lower hinge and then up to a piece which we need to build onto here at this time. The nose, this is our nose cone, fit in here. And notice we do need to cut out a section here. We make a line and snip so that this can out. We're going to need to take our nose fork, and it will end up going here and rotating. We need to create the hole in this area here. So let's go take this and work on the hole. Okay, we'll assemble our nose fork and wheel. Now, we went ahead and drilled the appropriate size hole in our arm that was to match in the fork itself. So our first step is to take the pre-welded bolt and plate, and that will go inside here. And there are some smaller holes. We can deal with those later. But if we have our threaded bolt here, on top of that we will place a washer and a thrust bearing and another washer, and that provides our bearing surface. And then we can take our arm and connect that up. Actually, this goes like this. So that's all we have, is that goes onto there. And then we're going to place our This eyelet here will provide our connection for the hydraulic cylinder. And then we can go ahead and put our castellated nut on here. Now eventually we'll drill the bolt to accept a cotter pin for the nut. I'm just putting that on finger tight, and also notice there are some more holes in there, I believe for rivets, though we need to check our plans. And that will give us then our bearing surface so that this can rotate. And then finally, we have our spring attachment. This is basically just a cap for the bolt, and we'll drill this for a cotter pin and also drill another hole in the bolt so we can cotter that in place. And this allows us to attach our spring to the tiny hole in the end here, and that spring will allow us to hold this in a neutral position when there's no weight on it. And we can attach this back into the float itself. And here we go with everything assembled. Notice the piston is tied in with and the piston's attached down at this end. And we have our rotatable and remember, a spring will keep this centered whenever the wheel is off the ground. So as it's coming down, this will automatically center. Because there is no steering, this is a castering wheel. Now we're going to work on the main wheel well. Start with bulkhead number 6. So I've removed bulkhead number 6 here and taken it out to our bench so we can attach the appropriate components. Here's our bulkhead number 6, and we have the forward part towards us. And these holes, of course, are where our side walls were attached. Now, our first step is to take these doublers. We have 2 of them. This is FL54, and they're going to end up going right down the center line on the front side of FL6. And in fact, we're going to attach them along the flange. So we're going to lay out a rivet line, drill them, and then back drill into the other flange, and they'll eventually be riveted together. They'll go onto the center line, and then we're going to trim them so that they don't go outside the boundaries of the edge of our float. And our existing holes for the side panels will be used also. We'll back drill those into our FL54s. There, I finished drilling along the lip and then back drilled into the other side, cleated them together, and now I have clamped them along the center line of the bulkhead on the front face. And if we turn it over, this will allow us to trace, because this will be the area that we want to remove and cut off, and same with up at the top. So I just took a pen and traced around there, both of the corners. And I'll take this over to a bandsaw and remove it. And here we have it all trimmed. Again, I just used my bandsaw and then re-clecoed these back together. Here's the bottom. And filed and trimmed as necessary for a nice fit so that it's not overlapping at the top or the bottom. Now ultimately, the holes along the edges will be used to back drill into this on both sides. I'm not going to drill them all for now. I'm just going to drill a couple and cleco this in place because we need to then turn this over and work on the other side. Now we're first going to create a hinge line across the top, and we'll do this using our plans to locate that dimension down from the top. And on that hinge line is going to go our FL62s, which is a pair of hinges. We need to first drill the pivot line, and I'll clamp these together and drill them. I will also make a line down the edge from that line so we can locate this on the bulkhead properly. But then we also need to drill the flange on both pieces. Now we'll have two of these. So I'll prepare these both, which will end up going about right here. Here I have our hinges pre-drilled and drilled through our link with 2 bolts. And then we're going to place this on the bulkhead, and we have our rivet line drawn across the top. And that's what we'll line that up with and center it left to right and make sure everything is parallel. And when we have that just the way we want, we'll go ahead and drill our holes from the hinge into the bulkhead and cleco them into place. And here we have it drilled in place and the operation of the pivot. Now we have another hinge that's going to go down at the bottom, down in this area. Now it's also important to know whether you're working on the pilot or the passenger side float. I'm working on the pilot side, which means over here is my inboard side. And our hinge has to go on the inboard side, whether it be the pilot or the passenger bulkhead. The hinge we have to make, and we're going to fabricate this out of a piece of extrusion, is something like this. And this is our FL63. We're going to start off with a piece of extrusion like this. And notice I've drilled a hole. That's going to be for this radius right in here. That makes it easier. And then I've simply used the plans to draw where I'm going to cut on the bandsaw, because we need 2 of these to mount for our lower hinge. I have the 2 hinges in place, clecoed, using our directions to find their location. And remember, this is the inboard side for the pilot's float, pilot side float. We drew our hinge line, and we have them 2 together, separated by the distance of the hinge, the distance of the cylinder, which will fit right inside there. We need to install this channel. Now I have pre-drilled a row of holes for rivets along the flanges, and this will be located underneath the pivot point for the link that's attached here, and it'll go approximately right here. And this will act as a stop for the channel. And I will go ahead and drill this. I'm also picking up 2 of the rivet holes from over here at the end, and use your plans, but that'll go approximately right there. And then finally we'll attach the link onto the bottom, which is this piece here. Now we'll have to drill the hinges for that to attach, and then that will pivot in this location here. In preparation for working on bulkhead number 8, we need to prepare our wheel plates. These are for the main wheels, and we have an outboard and an inboard. And make sure you look at the plans to understand which is the front versus which is the rear. Our links will attach up at the front. We'll do that in a moment. We first need to drill the hole for the main wheel axle. We're given a dimension in our plans from this hole to the pivot point here, and I made this a circle and found the center, incorporating that dimension. And I'm going to open mine up to 3/4 inch. Make sure you double check your axle. And of course the same thing for the other side. And we can drill these together to make sure we get the hole precisely at the same spot. So I'm going to go open this up, and then we can install our wheel, because we're going to need the dimension with the wheel inside between these so that we can prepare the attachment points on our bulkhead accurately. Now that we have our holes drilled, let's see if we can assemble our wheel assembly. Now I'm on the pilot side float, and this direction is forward. So this will be on the outboard side, and this will be on the inboard side towards the airplane. So from the outboard, we will insert our axle. That all the way through. And it will stop all the way to this grease fitting here, the flange. Then we'll have a spacer, and this will be for the brake assembly. We'll slide that on. Then our wheel, and of course the disc for the brake. Now when we're really going to put this together for the final time, the brake caliper will slide over this and attach to these 4 bolts. But for now, we're going to slide the wheel on, and there's a couple of spacers I simply pressed into place. The bearings are already mounted inside of the wheel, and that'll come out like that. And that leaves us then with the other section, which will go on top of here, and then a nut will go right here after we push it all together. And the reason I'm putting this all together now is that front side here will go to the link, and the back side is what we need for the dimension between here to attach to our hinges that we want to install on bulkhead number 8. So this distance is what I'm interested in measuring. It is in the plans, but it's just good to actually have that as the exact measurement when we build the hinges around this. We'll be working on bulkhead number 8. Our first step is to create some of the components. This is FL56. Now we're going to make this from a straight piece of stock. We have an angle there, and then at each end a small one, and then we'll clean it up to get all the teeth marks off from our bandsaw. And this will end up going on the back of our FL8, and the dimension is in the plans. I say back and front, we need to be careful because remember the bulkheads face each other right at about number 7 and 8. But this will go on the back over there. Then the section within the flanges, we're going to need to create our hinges. Now this is our FL65, and this has a taper. We'll cut that with our bandsaw from the straight stock, and a hole which we will precisely locate. And then its complement is FL64. We'll make this also using our bandsaw. And so these two pieces together will make up our hinge on one side, and we'll drill the hole straight through so that they line up very nicely. Now we're going to have a left and a right with each of these, and we'll place that next. On the bulkhead, we'll draw our hinge lines at the appropriate location and center lines, and then our goal is to properly locate our hinges on the hinge line. And the distance between these hinges is what is going to be set by our wheel plates that we put together. That's why we assembled them, so that we can measure them and transfer the measurement and then double check that they fit, so we get a nice fit. And check your plans. I believe there's a plastic washer in between the plate and each of these hinges, so we want to leave a little bit of room. But once we have these placed properly, we can lay out our rivet line and drill the holes, keeping in mind that we have the support extrusion on the back side, and I drew another line there so we can have our intersecting rivet lines as necessary. And here we have all the parts clecoed in place. Don't forget FL39, which is this piece right here. The very top here will have a bolt that goes through to the other side for the pickup weldment. And on the opposite side, we have our stiffener in place, the extrusion. And we'll have a little more work up here when we put the pickup on. For now, let's just test the wheel hinge. One technique I used for lining up the hinges while drilling was to take a very long drill bit that we've been using. And I didn't use the drill bit to drill the holes as much as I used it to get the position of the hinges by allowing the drill bit to keep them all in line from one to another and across to the other side. And here's a test of our hinge fit. And that'll fit in there very nicely. Here we have assembled bulkhead number 6 and bulkhead number 8. And our purpose is to kind of demonstrate how the main wheel mechanism works, because this is easiest to see now and a bit harder to see once it's installed inside the float. Let's take a closer look. Here's bulkhead 6 and our link attached to the wheel plates. Our wheel, of course, will go right in between here. The piston here, which we haven't installed, goes right down at this hinge and pushes the link upward. So if we can picture when that piston pushes the link upward, the gear is retracted. Here's the bottom of the float right here. And under the weight of the wheels, with the piston allowed to reach the weight of the wheels, we'll pull this down. The link will jam against our channel and lock the wheels in place so that it cannot go up. The only way it can go up is if we energize the piston again and it passes the link past this pivot point, and it can then retract up again. Here's another angle. And again, the piston will go from here to here. I have some clecos in the way, so it's not going to fit at the moment. And then with the wheels down and the wheels up. And looking at bulkhead number 8. Now we have reinstalled bulkhead 8 and 6 back into the float so we can see what they look like. Take note of the link. On the link is the tab where our cylinder attaches, and the nose of that tab will actually touch the skin when it's in its retracted position. In effect, the skin is in the way. Here's another view of it. We actually want to make a slot in the skin so that tab can slip through, and this will be an indicator that our wheels are in their fully retracted position. And here's a view of bulkhead number 8. We have installed the side panels into the wheel well, and what we have here are some slide channels that will attach to the side panels. And these will help guide the wheels as they travel up and down in the wheel well. These slide channels are mounted on both sides of the wheel well, and the direction and locations are in the plans. There is a piece of nylon strip that will be riveted to the surface of the channel, and that will help to further ease the movement of the gear up and down against these channels. Now we're looking at the back side of FL8, and we have to prepare for attaching the steel pickup. Now, using my plans, I've marked a horizontal line, in my case 95 millimeters down from the top, and I've also drawn 2 parallel lines to help me keep the pickup centered. We'll see in a second. Now, I'll lay this down. Here is the pickup, a steel piece, and I bent this just a little bit. For the most part, it was pretty much in the proper shape. 1.5-inch tube, and this is made out of steel. And this will fit. Be sure to check your plans on whether you're building the pilot side or the passenger side float. That'll make a difference. And this will go against the edge, and that's why I drew the 2 lines to help me kind of keep this centered and not skewed too far. And the edge over here will go along the edge of the bulkhead, and eventually will get riveted in, and we'll have some supporting structures also that will attach. Over at the far end here, we'll notice that they have sliced this at an angle, and that's good because we're going to end up putting a bolt right through here and then into the bulkhead. Now we may have to do some trimming. We'll check that out in a second. So this is where this is going to be located. Now, prior to putting that on, we have a couple of supporting L angles for stiffeners. First one is FL26. Now, what's unique about this is that there is a curve that was placed in here, and that will go along the edge here. And so I'll make this even with the edge. I obviously drilled some holes down the center per the rivet pitch requested. And I also did some trimming down at the end so it would sit nicely down here. Now, it is at this point here that we will eventually place a bolt to bolt our pickup on, right through here. So the purpose of this is to provide a nice firm support for the bolt that goes through. Over on the other side, we have FL38, and this is a straight piece, and this will go on the other side. I'll Cleco these in place. Now, I obviously drilled them and sized them properly, but this will be even with the edge of the bulkhead over on that side. I'll Cleco these in place, and then we can put our welded steel pickup in place and see how that fits. And there we go. And if this is a little easier to see, and the straight one over here on the other side. Now, when we put our pickup back in place, we will see that this part here is going to set on top of here. Let's take a closer look. When we place our tube all the way over, now I'm going to have to trim mine because I can't get it far enough to the left. But when I do, ultimately what we're going to do is place a bolt straight down into the lip of the bolt and then into our extrusion here into the back side. So we want to make sure we follow our line straight across. And when we have this moved all the way over to the left, we can then drill a hole straight down through there. The reason I have to trim here is if we look at the other side, we need to make sure that we get this all the way over tight to the flange. So that's our goal, to keep it tight to the flange, keep it straight, and then trim the other end so that it butts up against here, and then we can drill our hole. We will also have another bolt that goes straight through right about here, and that will go into this area here. Now, because there's a difference, there'll be a gap in here because of the thickness of the extrusion, we'll take a shim and place it right here. So the bolt will go through the pipe, into the shim, and into the back. And that bolt, of course, will line up with this line right here. And here we have finished installing the pickup. Notice the bolt, and notice to the right that is a hole, a 3/16 hole, which will also take a bolt drilled into the lip after we trimmed it so it would fit. And also notice under the bolt the shim we put in. And for the moment we have it clamped on the flange so that we keep it positioned properly. The back here. Here's the bolt that goes all the way through. Notice it intersects our extrusion. And then over here is the hole that is in the very lip of the pickup tube. And we'll put a bolt and a nut on there. And here's a view from the other angle. Notice we had to trim the end of the tube so that it would fit into the extrusion. Eventually, when we drill into the skin, we will drill into the fitting so that it hits both the flange of the bulkhead plus the extrusion that we added right behind it. So we'll have a double row of rivets. And the same at this side into our skin. We will have another set of rivets here and then the flange below. This same configuration is repeated for bulkhead number 4, where we have the other pickup for this float. We have reinstalled bulkhead number 8 back into the float, and we're going to examine where to drill the hole for the pickup tube. Notice our horizontal lines with the one in the middle, and that will help us locate exactly where to make the pilot hole. And here we have determined the location of the pilot hole. We will remove the bulkhead now and use a standard hole saw. This one is 2 inches in diameter, which is larger than we need, but remember the pickup tube passes through the skin at a slight angle, and of course requires a larger hole than the 1.5 inch diameter that it actually is. The hole is drilled through without any undue effort, and we can reinstall bulkhead number 8 along with the pickup tube. And notice we inserted the bolt so that we have it mounted in its permanent location. And from the outside, this is what it looks like. This will be attached with rivets and sealant. Now we are going to drill into the pickup weldment. Most of the drilling will probably be done from inside. Let's take a look. We are going to drill through our pre-drilled holes in the flange, and those represent the clecos we just saw on the other side. And the extrusion on the other side we have marked, and we will drill through it into the steel weldment. Note that very close to the bottom, my plans call for a bolt, an AN3 bolt, to go into that location instead of a rivet.
What are the consequences for having taken so long to dig government one?
We will also drill into the skin through the other extrusion we placed on the other side. After getting a couple holes started through the inside of the float, I found it easier to take it off the float and cleco it together, and then take it to the drill press and drill the rest of the holes out. And that way it just went a little quicker, and I got some nice straight clean holes that way. And here we've drilled a few more holes, and notice we have the bolt in its location. Now we still have a few more to drill along the very bottom edge, which is really the top, and along the diagonal side we'll have a row of rivets there also. And note the double row of vertical holes. That's because inside we have drilled through the extrusion into the skin. Let's take a look at FL4. The work we have to do with FL4 is going to be similar to what we did with number 6, in that we're going to have our forward steel pickup go across the top, so we'll have some of the similar components. We'll have an extrusion, FL38, along one edge, and then our extrusion with the curve, FL26, along this edge, and then on the back, a single extrusion, FL39. And so we just laid out the rivet holes per the pitch in the plans, and then in a similar fashion we will attach the pickup, which will go just like we had before. We're going to end up drilling a hole in our end, and that'll go right into here. We have our line 95 millimeters down, which is the center line. And then we'll put a shim in this area and a bolt through that into the extrusion behind it. So identical to the work we did on our previous bulkhead that also had the pickup. Now make sure you mount this on the correct side, because remember, things are upside down and it matters whether you're building the pilot versus the passenger side float. Obviously the pickup connection has to be on the correct side. Now we're going to look at installing the side gusset. Now this piece will span from bulkhead number 8 to bulkhead number 5. And it starts out as a rectangular piece of, looks like about 40 thousandths aluminum. We're going to slide it underneath the skin, between the bulkheads and the skin, making sure that we span all the way down to bulkhead 8, and we can go just a little bit past, and all the way to number 5. I'm going to leave about 70 millimeters sticking up at each end. And I'll measure that. And I'll clamp that in place. With it clamped in place, we can go ahead then and back drill through the existing holes at the edge of the skin for the full length. And I will also back drill a couple of the holes that it overlaps in between here. Now of course, before we do this, we want to make sure again that at each edge we are as far as number 5 at one end and number 8 at the other, because we want to definitely overlap those bulkheads to include them, to include the bulkhead, and then of course at the other end to include that bulkhead down at number 5. But we'll go ahead then and drill all the holes from one end to the other. And then what we'll also do before unclecoing this is to trace the edge of the skin onto this piece, because we're going to end up removing the piece above the edge of the skin, because this will be even when we're done with the edge of this skin. Now that all the holes have been drilled, I made a line, traced the edge of the skin. I'm ready to remove it. I also have drilled out at least the first 1 or 2 holes in each bulkhead. So one hole here, and then a couple of holes here. And the same with the rest of the bulkheads down the row. Here's the gusset after it was just removed after drilling. Now our next step is to make a line, and I'm going to mark my line 10 millimeters past the last bulkhead hole, so right there, and then the very same at the other end. And with those 2 lines, I'm going to put a straight edge so it will look something like this. I can then draw a line across this straight edge, and that will provide the other line on which we will cut. And obviously we're going to also remove the part above the edge of our skin up here. So the gusset will be this part in the middle. And then we have one more set of holes to drill along this edge.
Nationwide urge you to listen to the voices of meningitis. Get preteens and teens vaccinated against this rare but serious disease. To learn more, go to voicesofmeningitis.org.
And here's the outline of what our final gusset will look like. Now we do need to drill another set of holes 10 millimeters above this line at the correct pitch all the way across. And also we need to make an arc here as per the directions. I'm going to use something such as this to allow me to make the curve, and I'll just simply trace around that. My plans show that 50 millimeters past this rivet line is where we depart downwards, and I just used a round cup here to come up with the arc to join it. So that's where we'll ultimately cut it out. Now here is the gusset with the additional holes laid out. We'll go ahead and drill those and then trim the gusset to its proper size. Here's the completed gusset. Both sides drilled out and the part trimmed. Notice in the center section I have not finished the arc. I need to clean that up. But I can go ahead now and mount this, and then we need to drill the bottom set of holes into the float skin. And we can go ahead now and drill the lower set of holes into the skin, or the upper set if you have the float inverted to its proper position. And here the gusset is completed. We used a rotary file to help remove the material around that curve. A rotary file fits into an air tool, spins very rapidly and removes the metal very quickly. Now we're at the very back end of the float. This is FL11, the very last bulkhead. And we have a hinge to put on, FL42. And this came pre-formed. And there's a dimension from our plans, and that'll be mounted on the outside. Also, we'll drill our rivet line to the pitch indicated on the plans. And then on the inside is a doubler, and the doubler will fit right in here. Gets 2 holes up here, and then of course the holes from the hinge coming through it. In order to install the walkway, we need to turn the float 180 degrees, upside down, but actually it's right side up. Now I have created 2 V blocks. I simply traced the angle from the bulkheads onto a piece of plywood and made 2 of them. Made one end higher because the float is actually larger at one end, and pulled the float out of its cradle and onto these V blocks. This way we have access, of course, now to the top side. In preparation for installing the walkway, we want to remove any clecos we have in place along the center section, because our flanges will be test fitted as we lay the walkway on top of here. So I removed all the clecos from all of the bulkheads. Here we have placed the walkway on top of the float in its approximate location. We have not drilled anything at this time. The plans show where the back end begins, just beyond the bulkhead. And we get to see where the splice between the 2 sections come out, because this walkway is in 2 sections of equal length. And then the end, which comes up almost all of the way to the front, so that it at least catches the rivet line. Starting from the rear, I placed a mark 15 millimeters from the edge of the walkway, and that will line up with the rivet line. At the center, where the splice is going to go, I marked the center of our splice. It's going to go on top and right at the seam. And I'll mark then on both pieces. Then at each rivet line we want to place a mark on the flange, because we're going to drill those holes either from the inside or use a hole finder, strap duplicator. So both sides we want to mark. Now we will lay out our rivet lines between these marks, remembering not to drill into these marks, because those holes already exist underneath and we need to drill them differently. With these marks in place, we can then lay out the rivet line for all of the holes in between.
And do certain times in our culture, Marlo, create comedians? In other words, Chris Rock.
And here we're laying out the rivet line for the splice section, FL27. We'll have some rivets along the edge and some 24 they want along the top, and of course the edge. And we'll use this to join the 2 walkways first, get them nice and straight. And here we've laid out the rivet line and we're pitching between where the bulkheads lay, because we're not going to drill through the bulkhead intersections. Those will come from the other side. Those are the existing holes. But we're laying out all the other holes, which we will pre-drill now along the flange. And of course our splice plate. And we'll go ahead and drill with the other piece connected also. Note how this and this hole on a typical bulkhead will be the ones that go into the flange. So all of the bulkhead holes will drill from the inside later, but we'll certainly pre-drill the outside ones first and leave these open. Now of course the step doesn't go all the way to the back, it goes to the next one. Here we have pre-drilled and clecoed our step. Notice that we have not drilled where the bulkhead rivets come through. We will defer those and drill from the inside to get the exact location for the hole. Here's our splice between the two walkways. Yours may be different. In fact, yours may go on the inside rather than the outside. We had an earlier version. At this time, we can drill through all of our pre-drilled holes in the flange, except for the ones at the bulkheads. Those, of course, will drill from inside the float outward. The upper rudder hinge is located at this location to line up with the lower hinge, of course. While not displayed in this video, the following are important procedures that need to be completed in order to finish the floats. All holes in the entire float assembly must be drilled out to final size. The plans must be carefully scrutinized to verify what the proper hole size is for each location. The entire float structure must be disassembled for the purpose of deburring all holes. For an excellent fit between mating surfaces of parts, there must be no burrs or metal chips remaining from the drilling of the sheet metal. It is a simple matter to run a file across the metal to accomplish this purpose. A decision must be made as to the primer to be applied to the interior surfaces of the float. Also, will the interior be painted in addition to priming? The supplied marine sealant must be applied to mating surfaces just prior to riveting. The majority of rivets used on the floats are a special sealed end pop or pulled rivet. This makes installation very easy using a standard rivet gun. A portion of the rivets are small, solid rivets, but all of these require just a hand squeezer for installation. A small number of stainless steel rivets are used in areas where strength is critical. Those that desire to utilize conventional bucked rivets can still do so, but this is not specified in the plans. Some of the final steps include installing the wheels and their associated hardware and plumbing the hydraulic hoses to the cylinders. Floats typically require a protective coating of paint on their outer surface. Attaching the floats to an aircraft require additional rigging components that are not included with the float kit. Along the walkway, you will notice several black plastic plugs. These cover up holes that need to be made to allow siphoning out water from the compartments created by the bulkheads.
Donc quand on va avoir décollé, dès qu'on atteindra ce point,
Albert, tu regardes par là.
faudra que tu essaies ça, Mathieu, demain, si ça va mieux. C'est marrant, les gars ils mettent bien des deux temps pour prendre de l'air, mais sur un 3 axes.
Non, non, c'est bon, hein.
My name's Bob McDowell. I live down in southeast Iowa, about 90 miles north of Mexico, where they make the Zenith aircraft. And I went down one weekend and flew a 701. Had the most fun I ever had in my life, and I decided to build one. So I got the kit, came home. Let's see, I bought it in 2007, and I spent every night and every weekend for about a year, and here it is, having fun. But I flew it for about a year, and then I decided I want some amphibious floats on it. So that's what we got.
Are those Zenith floats?
Yeah, yeah. And I land in the Mississippi River. We've got plenty of water around where I live in southeast Iowa. And I landed behind my house. I have a 1,200-foot grass strip, and I was kind of worried about that with the small tires, and does a good job. I use up about 600 foot of runway, and I can get in and out of that 1,200 foot real good. But flew it down to Lakeland this spring with Sebastian, Roger, and Steve. Had a real hoot going down there. We made several stops, had a lot of fun. I always carry my Popel pocket fisherman in the back with me. And Steve was kind of laughing at me. He said you couldn't catch anything on that fishing pole, but we went out in the backyard, caught a couple catfish, and then he ordered one on eBay. So, but it's a lot of fun. You got a lot of choices with floats. It's every time I look at a lake or a river, it's a runway now.
Training to get into the float flying.
Well, I got my seaplane rating, you know, about 30 years ago. I'm telling my age now, but I think it took about 5 or 6 hours. And then I asked the FAA guy, what's going to take to get recurrent? I haven't done that for a while. And he said, go out and do 3 landings and takeoffs. So went to the river one day right after the ice was out, and a friend of mine says, I think I better bring my flatboat down and keep an eye on you. And I said, it might not be a bad idea. But was no big deal. Just flare out and land like you're on land, and when you touch down, pull the stick back, pull the power off, it settles right in. And so I was having so much fun. I did about 6 of them and never crashed it. Just got to remember, gear up on water, gear down on land. I wrote it right on my dash. But no, it's really a lot of fun. I fly a 310 Cessna, and I always thought I'd like to go faster and faster, but I think I like going slow, low and slow. A lot of fun. But floats.
Did you build floats?
No, they came as, and all you have to do is get your height above the float setting, go from the spar back a certain measurement, drop the plumb line down so it meets your step. 3-degree pitch up on the plane. And once you get your float situated under, I had my plane hanging on the ceiling of the shop, had it flat. The floats were pitched down 3 degrees. You drop your plumb line, get them situated forward and back and side by side. Get your spreader bars cut and fit, get the right width. Once you get that all squared up, you cut your first strut and get it made. The tubing and the brackets were there. You bolt them together, cut your tubing to fit. One's made, the other one's exactly the same. You put it in, come back, cut this one, fit it. Do the next one, and then your diagonals, fit those in. And you got your cable bracing, squares it all up. And I put quick couplers on it because I thought maybe I might want to go from wheels to floats, and that way you could pop your quick couplers, don't lose your oil out of your hydraulic pump and your brake lines. You don't have to bleed it. So I could probably get these floats off and the wheels back on in a couple hours. Not too bad. I don't know, a friend of mine's got a de Havilland beaver on floats, so I thought this looked like a little beaver, so got his scarf and his diaper on there and everything. Where my front wheel bolted on, I was trying to figure out how to get this thing in the hanger. It grew in the back, you know, so I thought, well, I got to jack the front end up to get the tail down. So well, I'll make a hinge. I made a hinge with a pipe, front wheel on it, and then a handle. So I pry it down, the wheel comes down underneath, and the tail goes down a couple foot. So, and then I can wheel it in the hanger. So that's a good thing to have that hanging on there. Put a little LED light and just keep playing with it, finding more things to do. Changed my doors, changed a few things on them.
The prop is
It's a warp drive.
with definitely with the leading edge.
Yeah, they nickel coated it. They said it'd be better, but on these floats, I don't get water on the plane unless it's really choppy. But it's usually pretty dry.
And what did it do to your either cruise speed or ability to climb with the extra weight and all that?
It really didn't make much difference. I mean, it's pretty much 80 mile an hour with or without, you know. I'm running about 5,200 RPM, not full bore, but 4.8 gallons per hour.
That's a PS, I-12S.
Yeah, that's the S. And yeah, it's nice to go in and put 9 gallons in it instead of about 100. You know. But
And how many hours you have on it so far?
got about close to 200 hours now.
100 hours.
Yeah.
Over what period of time, roughly?
That's been a year and a half. So when it's sitting in the back behind the house in the hangar, you know, at night, drag it out and go for a flight, you know. It's just surprising how many hours you can put on a plane when it's sitting there, you know.
How many water landings would you guess you've had? Just too many to keep track of.
Probably, yeah, 60. Yeah, it's hard to tell. We were down at Lakeland and went over to Splash In, and that was fun. That was a good deal. And I 15 mile an hour crosswind. I landed in the wind, and then I had to taxi across the crosswind, and I hadn't had much time in a seaplane, you know. And this is going to be all the people standing there watching. I thought, oh, this is going to be embarrassing. Usually they'll windcock into the wind, you know. I put my rudders down, just like a boat in current, and taxied right up the ramp like I knew what I was doing. Pumped the wheels down, shot up out of the ramp. Never done that before. And the guy came up and says, "You look like you've been doing that for a while." And I said, first time. But it's got a good set of water rudders on it.
And those rudders you can deploy up and down
Yep.
automatically. Wow, let's go take a look at it.
Yeah, it's got a cable here and a release, and you just drop them down when you get in the water. I put a little longer throw on those two. Guy was telling me about that. He said normally they pivot off this horn here, your rudder horn. I made it a little bit longer, so when you pull it over, you got a good throw on the water rudder. Gives you a little more control. But just keep playing with it, you know, figuring out different things. It's fun. It's part of it. Experimental, that's what's great.
And how about your paint job? Did you do that or have someone do it? Or?
Well, my buddy has a body shop, and we had to get it all scuffed up, clean for him. And that's a lot of work. And we scuffed and cleaned, and we got it done once. He said, "Do it again." We did it 3 times, but it turned out, you know, pretty good.
And all that additional scuffing, he just really wanted to make sure the surface was just right for his paint.
Yeah, aluminum, you know, when you first scuff it, it's dirty.
Right.
You got to get all that dirt out of it. And self-etching primer went on first, and then he painted it with a kind of a white cover-up paint, so that you only have to make one pass with the expensive paint. But a lot of weight in paint, but I don't think I want to polish on it all the time, so painted it. And I don't know, a lot of fun.
How many hours to build it? How many hours?
I was 1,200 and some hours. I spent most of my time thinking instead of cutting and stuff, worried about messing up, you know. And you still do, but you just got to go do it. And once you get started, everything seems to fall in line, you know. You're nervous, you don't want to mess anything up.
Did you spend much time with the wheels originally, or not? Did you go to
About-
practice right away?
I was about a year with the wheels.
Okay.
Yeah. And Roger and Sebastian, they said, you ought to just, you know, get used to playing on wheels. And so I was anxious to get the floats on after that.
So in effect, you're saying that anyone with a 701 that's proficient at flying can do the float thing if they want to.
Oh yeah. It's a little more rudder, you know. It'll give you a little more yaw around. You kind of have to keep it on your ball, kick it around. But I like the advantage of it. The runways are everywhere, you know.
Now you do have to be a little more careful on your paved or grass landings because you don't have quite the spring, I would assume.
Yeah, but I'd rather land on grass. It's just, you know, it's a little more forgiving and saves your tire wear and everything. But at home I got the grass, and it's a little rough, but not bad.
Your panel looks real nice there.
Yeah, I got a couple little Becker radios, you know. They don't take up a lot of room. They work really good. Encoder, and my Garmin 496 and a road map. That's all you need. But yeah, you always find something to work on and just mess with.
A little extra, isn't it?
Oh yeah, just caterpillar grommet. Yeah, they roll around there. I can't remember how many gallons of paint we put on it, but I kept telling them not so much, not so much. Car painters, you know, they don't think about weight like airplane guys do, and they want to blast it on. But it's a good paint. It's Standox car paint, clear coat, base coat they call it. Then on my decal man, I said
Oh, that's a decal. Okay.
yeah.
That's beautiful.
when I had it on wheels, I said, I want something that looks like a splash of water, because I knew I was going to do this eventually. So he came in for that, and then got the floats, and he put that on, and my little beaver up there. So
Did the floats affect your weight and balance significantly, or?
not too bad. There's a little bit of change, but not really. It's pretty balanced. I'm going to do a little adjusting on my flaps. If I could tweak them down, I'm carrying a little bit of pitch up attitude. And I think if I tweak my flaps down just a tweak, it'll bring my attitude back level again. And that's just something to get it back home in the hangar. But
How far a trip was it to here? What was your experience flying into Oshkosh? Was this your first trip into Oshkosh, or?
I flew it up here last year on wheels, and wasn't real busy when I came in. This year it was like a beehive, and it wasn't bad, but you know, I was slow.
Right.
So I'd kick the rudder around, see what was behind me, and I'd look, but I wasn't worried about the guy in front of me. But it was good. It was no problem getting in and out of here. And thinking about get out here early, I might go up Door County way and skip up to the UP and over to Beaver Island, and that looks like it'd be a nice trip if my wife doesn't kill me first.
Did she come with you, or?
No, she stayed home. Yeah.
Oh yeah, with the palm tree right there. He dropped something. Yeah.
But you know, we are at the right position here because there are big pockets over there.
No, this is first. This way. Yeah, but it's great. So it's rough
That's our earth. At the, put out the air, all the oil and over the fence. So now it runs on the wind. That's all.
down on the water.
Yeah. With their Viking powered Kit Fox. This is 2016, and we're over to visit Joe Piers. He's going to fire up his new gyrocopter today with a Viking 130.